The training packages TP8016 from Festo Didactic are practical learning solutions for building fundamental skills in electromechanics. Each package provides the necessary training equipment to study and engage in hands-on experimentation with three-phase rotating machines, permanent magnet DC motors, or power factor correction. Complete courses are available to speed up lesson planning and guide students during lab sessions. They feature the necessary theory as well as step-by-step learning exercises. Courses are available on the Festo LX portal or as PDF workbooks. Let's look at the hardware included in the training packages. Note that most modules are protected against short circuits, overvoltage, and overcurrent, and are designed to endure many decades of lab work. Modules can be used as tabletop devices, although it's more practical to insert them in a workstation equipped with standard A4 rails. For each exercise, students wire the modules with safety lab cables according to the electrical schematics provided in the courses. To study the DC motor, students can use a 48-volt battery pack as a source of fixed DC power, or our versatile dynamometer and power supply module configured as a DC power supply. In this mode, the unit acts as a variable DC voltage source, positive or negative. Please note that this power supply is reversible, as it can both source power and sink it. For three-phase machines, the power supply module can provide the three AC voltages feeding the stator, as well as the DC voltage required for the field. Three load modules are provided to load the machines running in generator mode or to compensate their power factor. With the resistive load module, students can connect up to 3 resistors in parallel in each phase of a three-phase load using its 3 banks of identical resistors. The same 3 banks of 3-component structure is used in the capacitive and inductive load modules. To make measurements easy to understand and perform, students use the data acquisition and control interface that offers optically isolated voltage and current inputs. This data is sent to the computer via a USB link and is used to display all relevant parameters: active, reactive, and apparent power, power factor, efficiency, impedance, phase shift, and so on. Using the dynamometer as a torque source, a speed source, or a mechanical load emulator, students will study the behavior of permanent magnet DC motors, as well as squirrel cage induction motors and synchronous motors and generators. 2 methods can be used to couple the motor and dynamometer: side by side with a timing belt, or face to face with a coupling sleeve. In both cases, the machines can only be put in motion if the protective cover is in place. The 4-quadrant dynamometer power supply is connected to a computer via a USB link. With our LVDAC EMS software, students can monitor the torque, speed, mechanical power, and efficiency of the machine under test. They can also produce standard graphs like a torque versus speed curve. Using the dynamometer to drive the synchronous generator, students also learn how to synchronize a generator with the power network. With the help of a synchronizing module and a synchroscope, they will see how energy can be pushed onto the grid. Finally, the topic of power factor is studied in detail, from its cause to the importance of correcting it using banks of capacitors. Students learn the distinction between plant-wide and distributed compensation. They find the right capacitive values to achieve proper compensation, both in single-phase and three-phase applications. In summary, the training packages 8016 ensure that students develop a strong practical understanding of rotating machines, both in generator and motor mode. Thanks to their modular design, these training packages can be easily combined with other packages or expanded with individual modules to cover topics in power circuits, power electronics, and renewable energy. They are a cost-effective solution that adapts to evolving training needs and budgets.